Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson. Today we're going through a series of questions to review a midterm for one of my students, and we are on question 4 of this midterm. So this question asks us to find the derivative of this particularly nasty function, the natural log of the fifth root of the product of x to the sixth minus 2x times x to the negative 1/2. And honestly, you could do this with the general derivative rules, the power rule and the product rule, but that's really not what you want to do here. You've probably seen this in class or seen something like it in class. When you first approach logarithms in pre-calculus or algebra 2, it's kind of like, well, where is this ever going to be useful? Obviously, there's some great uses in science and economics and places like that. But one of the kind of the more underrated places that it gets used, being useful, is here in this sort of problem. And we can use logarithmic expansion to make this problem far, far easier. I'll show you what I mean. So we're not even going to bother taking the derivative yet. We're just going to continue to work through this problem here and get everything pieced together. All right, so I've got the natural log of, and then I'm going to take that fifth root and I'm going to put it up as an exponent here. So we get all this, and then all of this is raised to the 1/5 power. So this 1/5 now can come out front because it's a power inside a logarithm. So we've got y equals 1/5 times the natural log of now just a product. X to the sixth minus 2x times x to the negative 1/2. All right, so now we've got a product inside a logarithm. Products can be expanded to sums. So this becomes y equals 1/5, and now this will be on the outside of the sum, the natural log of the first factor, x to the sixth minus 2x, plus the natural log of x to the negative 1/2. Okay, almost there. Now, when we have a sum or a difference inside a logarithm, there's really not much we can do about that. We could, if we wanted to here, we could pull out an x, and then we get another product. You could. I'm not going to. And the last thing I'm going to do is take down the negative 1/2 out front of that particular logarithm. So we get 1/5 times this expression in here, x to the sixth minus 2x, and then minus 1/2 times the natural log of x. Okay. So now we've done all that work, but remembering your log expansions, that's going to be some good work, and it's going to help us a lot in this next step here. Let's do one more cosmetic step here, and we're going to pass that 1/5 into everything here. So we get the 1/5 times the natural log of x to the sixth minus 2x minus 1/10 the natural log of x. Okay, so now we're ready to take the derivative. So y prime, so we've got this constant, this 1/5 constant, times, now the derivative of natural log is 1 over the argument, and then times the derivative of the argument, which is just a polynomial derivative, 6x to the fifth minus 2. And then minus 1/10 times the derivative of the natural log of x, which is 1 over x. So now we've got, that's the derivative. I mean, there's a few things we can do to clean this up, but you could box it up and say, look, I found the derivative. Y prime, I'll do one bit of cleanup here. Y prime is equal to 6x to the fifth minus 2 all over 5 times x to the sixth minus 2x, and then minus 1 over 10x. And that's it. There's your derivative. Thank you for watching, and I will see you in the next video.